Hello and welcome to Lesson 2 of our Algebra 1, Unit 1, Concepts 4679 unit. So, today's objective, scholars will interpret and compare linear functions. So today we are going to be interpreting and comparing linear functions. So here's our first problem. 3 cars are traveling to the same campground along the same route. The cars began at the same place, but at different times. Car A began the trip at noon, and cars B and C began the trip at different times before noon. The miles traveled by cars A, B, and C are represented respectively by the following graph, table, and equation. So if we look here, we can see that for car A, we have a graph. Car A shows our time afternoon in hours and our distance in miles. For car B, we have a table. We have time afternoon in hours and distance in miles. And for car C, we have an equation where D represents the total distance and T represents the time afternoon in hours. So the question we are going to be answering is, at what time, if ever, will car A pass each of the other cars? Describe any assumptions you made to justify your answer. So, it's very difficult to compare across different representations. I can't look at this and tell you any answers. I've got a graph, I have a table, and I have an equation. The easiest thing to do is to put all of the representations onto one representation. So, we could try to put all of these onto our graph. Let's try that first. So, I'm going to use red to represent the distance car B travels. I know that at hour 1, it was at 110. So I'm going to come here, hour 1, 110, and put a dot right about there. Hour 2 is at 175, 2, 175. Hour 3, it was at 240. Again, that's not real easy to put on this graph. So I can make a line, right? And I can sort of see where that is. There's car B. Now let's try to do the same thing for car C. So I'm going to do car C in green. So I know I start 0, I'm at 20. So I can put a dot here, 0, 20, and then plus 68. So at 1 hour, I'm at 88. Which is like right there, I guess. At 2 hours, I had another. But you see how this is, it's nice. I can see that I probably get past it, but it's hard to do this on a graph. So the other option is, I can put all of them on one format and use a table. And I think for this one, that's probably my easiest thing. So I'm going to put all of them into a table. So I did car B already because car B was already in a table. So let's do car C first. Because car C, we're just inputting values for T. So at 1 hour, say 68 times 1 plus 20 gives me, 68 times 1 plus 20 gives me 88. So for car C, I'm at 88. And then I add another 68 and I'm at, of course, I probably should have done this real quick. Add another 68, that takes me to 6. And 6 and 8 is 156. Add another 8, I'm at 70 here. 224. And another 68. I'm at 292. And another 68. I'm at 360. Okay, so there's my car C. And all I did was put in the values. So then let's look at car A. Car A, I have this lovely graph. And it's not super easy to read, but I can see at certain times it's easy. At 2, it looks like I'm at 150. So if I'm at 150 for 2, then I can say that at 1, I was at 75. So that 3, I'm at 225. At 4, I'm at 300. And at 5, I'm at 375. So, now that I have them all in one format, I can move on to comparing them. Here we go. So, here it is all filled in for you. So, at what time, if ever, will car A pass the other cars? So, let's look at comparing these times. At 1 hour, it hasn't passed anything. Even at 2 hours, we have not passed anything. At 3 hours, sometime between hour 2 and 3, I pass car C. So, you write that. Car A passes car C just before 3 p.m. Now let's look at when we might pass car B. So again, I'm comparing. So I'm still behind them at hour 4, but at hour 5, I have passed them. So I would write car A passes car B just before 5 p.m. Because remember, these are hours afternoon. So the last thing it asks us is to describe any assumptions you made. So what assumptions did we make? We assumed that these were all linear. Here, write that down. We assumed they were linear, that they traveled at the same speed, constant. They had constant speeds, constant rate of change. That's really the only assumption we made, is that they're traveling constantly at the same speed. Car A is always at 75 miles an hour. Car B is always at a different speed. Car C is always at a different speed. So, good luck doing your classwork, and you guys should be set to compare some linear functions.